Hey guys, welcome back to Chilifili, and in this video we're going to see about multivariable linear regression using normal equation. So in my last video I showed you guys about how we can implement simple linear regression using normal equation, and in that video we talked about how we can find the value of CO2 emission for a car on the basis of its engine size. So we only take into account its one dependent variable and one independent variable. So in that case, our independent variable was our car's engine size, and our dependent variable was the CO2 emission. And we tried to predict the value of CO2 emission from our engine size. And as you can see here, there are many more variables that we can take into account here, like its cylinders or its model or fuel type, but there was a limitation of simple linear regression that we can only take into account one variable at a time. Okay, so to resolve that limitation, we are now using multivariable linear regression. So what happens in linear regression is we can take into account more than one variable. So we can predict the value of our dependent variable based on more than one variables. Okay, for example, if you want to predict the price of a house, then you can predict it using its area, its type of neighborhood, number of bedrooms, and so on. So first of all, we need to know what kind of formula we are going to use. So here we are going to use the formula called normal equation, where theta will give us the value of each of its coefficient value, and we are going to see what are they. And x is matrix, and y is also a vector. Okay, so what goes into the matrix x? Okay, so the matrix x always has the first column as 1 because it is the coefficient value of a beta 0, so it is always going to be 1. Then the second column of matrix x is going to be its input feature. So in our previous video we only take into account our engine size, so here is only one column for engine size, and here is the y value, so that is our variable or vector we want to predict the output of. So in that case it was our CO2 emission. So this was our engine size and this is our CO2 emission. And now what we are going to do is we are going to add more features, so there will be more than two columns here. Okay, so let's get started. So here is the hypothesis function, that is beta 0 plus beta 1 into x1 plus beta 2 into x2 and so on. So in our previous video we only take into account only one feature, so it is in our previous video it is only going to be limited to x1. So but in this case our hypothesis function will last until n number of features. Okay, so let's move onwards to the coding part. Okay, so first of all we need to import the required libraries, so that are the pandas, numpy and matplotlib. We are using pandas to read our CSV file, and numpy for calculation and matplotlib for visualization. Okay, so why don't we start with the Jupyter notebook. Okay, so here it is. So we are going to execute this code one by one, and let's see how it works. Okay, so we are going to first import the required libraries and then reading the CSV file here, and now I'm going to print the first 5 rows of our data. Okay, so as you can see here we have 4 columns that are age, credit rating, children and loan. So now what we are going to do is we are going to predict the value of loan based on these three features, okay, that are age, credit rating and children. Okay, so here we can also see the name of columns. Okay, so here what we are going to do is we are going to store each of this column in one variable, that was x1, x2 and x3. So here x represents our input variable and y is our output variable. Okay, so let's run it. Yes, it works perfectly fine. Okay, so in my previous video I also talked about how we can add or multiply matrix, and I also made a separate video on matrices. So if you want to check it out, then I will put the link in the description. Okay, so now we want to, okay, I think I need to reload it. Yes. Okay. So this works fine. This is good. Okay. So here we are. So here we are going to see the shape of our variables that are x1, x2, and x3. So here you can see it is 1, 3, 3, 8. And okay. So now what we need to do is first let's just plot this data. Okay. So here you can see we have already plotted it. The first one is number of children versus loan amount. The second one is credit rating versus loan amount, and the third is age versus loan amount. Okay. So now what we have to do is we have to convert our data frame or our series into NumPy arrays. So we can add it in our matrix. So here we go. And now I'm just printing here the number of rows in our data set. So these are 1338. Okay, you can see it here. That was 1338. Yes. Okay, so moving forward. Okay, now what is this? Now x bias is our first column that we discussed here. Let me just get here. Yes, this is our first column, so I am going to define it as x bias. So it is always 1, as I told you earlier. So I'm going to use the ones function of numpy. So it will give us a column that has the length of n. So that are our number of rows in our main data set. Okay, so this works fine. Okay, now, okay, wait a minute. I think I need to show you something. So let me print the shape of our x bias. So you can see it is there is 1338 rows and one column here, and our data set has shape that was something different. That was like this. So we need to reshape our data set or reset our x values. Okay, so now I'm going to rename it by x1 new, x2 new, and x3 new, and going to reshape it. And this is our new shape, that is n comma 1. N is the number of rows and 1 is the number of columns. Okay, so this works perfectly fine. Okay, so now what we want to do is we want to append our data into a real matrix or our big matrix. So here what we did was we take our first column, or that was x bias here, and this is our second column, so we just appended it here. So since we have more than one feature, then we have to append more columns here. Okay, so first what I did was take the first column, that was the one column, and then appended it with x1 new, then take this new column and append it with x2 new, and then take this new column and appended it with x3 new. Okay, so now let me just show you how it goes. Yes, so you can see it. The first column is 1, and the second column has the age, and the third column has credit rating, and the fourth column has number of children here. Okay, let's just quickly check it. The first row is 19, 27.9, and 0. Okay, you can here see it, 19, 27.9, and number of children are 0. Okay, so let's move ahead. Okay, so now we need to find the transpose here. So why do we need to do it? Okay, so let's just quickly get to the equation of it. Yes, here is our normal equation. So what we need to find is the multiplication of x transpose into x and its inverse, and then the multiplication of x transpose and y. So we will do it step by step. First, what we are going to do is find the value of x transpose here. Okay, so this function will give us the value of x transpose. Okay, and now what we are going to do is we are going to multiply it with our original matrix, that was x. Okay, so here I'm going to perform the dot product here. Okay, and now we are going to find the inverse of it. You can see it here. Okay, now I'm going to find the inverse, and now I'm performing this action, that is x transpose into y. So once again matrix multiplication, that is dot. Okay, and now it will, if we multiply both of this matrix, then we have our theta value. Okay, okay, here we have it. Okay, so now what does this represent? This array represents this. This variable is our beta 0, this is beta 1, this is beta 2, and this is beta 3. Okay, so now I'm going to just print it and assign it some variable. Okay, so now what we are going to do is we want to predict our output based on number of children, age, and credit rating. Okay, so what we need to do is we have to just give it this variable, that is beta 0, beta 1, beta 2, 3, age, credit rating, and children. So our output function will be based on these values. Okay, so why we are writing this here? Okay, let me just get here and show you. See, this was our hypothesis function, right? Okay, so here we are going to say beta 0 plus beta 1 into x1. See, if it was just a simple linear regression, then we just have stop right here. But since it has more than one variables, then we are going to take it further. So in our case, we have three variables. So we will go to x1, x2, and x3. Okay. So we have our beta 1, beta 0, and beta 2, and beta 3 value. Okay, then we are going to just multiply it simply. So it will return us the predicted value. Okay, so now we are going to predict our value. For age equals to 90, credit rating equals to 27.9, and children equals to 0. So let's see what it gives us. Okay, so it is the 6905. Okay, so I think that's it for this video. And if you guys enjoyed this video, then please hit the like button. And if you guys want to check out my blog, then I will put the link in the description. I always post all my articles here. And okay, once again, thank you for watching, and I will see you guys in the next video.